I think you were speaking on mute.
Yeah, yeah. Can you hear me now? Sorry, I just need to.
Yes,
What
yes.
do you? Yeah, yeah. So we did add and then pop and we did remove S1 dot. So we need to quickly discuss all this one by one. And yesterday we had discussed, started with set, what is set, and the importance of set, difference between set and other linear data structures. Okay. And then all that we discussed in yesterday's session. So now there is another method. Let's complete this API today. Let's complete all these methods one by one. So I think, ma'am, somebody is asking me that she is not able to listen. Ma'am, you have. I believe there is some issue for you because all others can listen to the audio, ma'am. So you please check on your side. Anybody has any issue other than the ma'am who is asking about the audio?
Yeah, I
Everybody.
joined, sir. Now I can hear you.
Yes, yes, ma'am. Thank you. So remove update. Update is something which okay, let's go with this. So if you want to merge two lists, it's something we discussed sometime back with lists as well. Okay, if you want to combine two lists, then we need this update method.
Yeah, it's responded for the same.
Yeah, I just sent it back. Okay, so
Okay.
let's take one more set here, something like S2 equal to take some values here, friends. Something like S2 equal to some 10, 20, 30, 40, 50, something like that. Okay. And then S1 dot update of S2. Just pass this. So these two, this update method merges so two sets. Like this is discussed even in list as well. That method is extend. Here we call it as update. Let's try to print it. Print of S1. Let's see what is the output. So let's run this. Just check only, observe only for the last thing here. You can see here. So what is the first one? We already have 10, 20, 30, 40. 30, 40. Yeah. Yeah, we popped up everything, right? Yes. Also, we did a pop yesterday. So by the time we finish, we just have. Let me print S1 as well so that S1 has 1, 2 first, and then we added all this. Let me just print S1 before I think we have only one element by the time. So it should also have this one. S1 dot update of S2. Run this. It should also show one as well, means this is having different purpose. Let me just quickly check on it. Or else we do one thing. Let's take different values altogether and run this now. S1 dot, and should we, yes, I don't think we need to assign to anything. Yeah, this is perfectly okay. See here. You don't need to assign to anything. because this is not the right way of doing. Okay. Now you can see all that one value is left behind, that is 30. You can see that 30 plus remaining all other values you can see here. So what is that it is doing? It is merging these two lists S1 and S2 friends. That's what update method do here. When I say S1 dot update of S2, merging two lists. Okay. We printed it. So next one after this is what else do we have? So this is clear, right? Generally, what update does is just merges two sets, merge two sets, or combines two sets, whatever we say, or combine two sets. That's what merge is doing. Okay, that's all, friends. Okay, next after that is next method. Let's take up next method S1 dot merge is over. These are all set specific methods. We'll take them as all this in one shot. Okay, all set specific. We'll finish. Other than all that, okay. Copy, we know very well what copy does. Copy clear, removes everything in the set. It just makes set empty. And copy is used to copy a new object, new set objects from existing one. That's what copy does. And update we just discussed, remove. Union, these are all set related set membership methods like union, difference update, intersection, all that. We'll just do that as well. Just would like to finish other things. Okay. Next, copy S1 dot copy. Okay. S3, I'm taking copying to S3. Now print this S3, print of S3 here. Yeah, let's do one thing. Right click and run this. You can see here S3 is also same as this one. Which one? S2, not S2, S3. Just a minute. S print of, already we have S1, right? Yeah, this is perfect output. Why? Because we did update, right? When we update, even whatever values in S2 got updated to S1. So whatever we are seeing here, S1 is this, S3 is this. So all values of S1 got copied to S3. But maybe you can ask a question, what is that? We are not seeing same order of values in S1 and S3. That's quite happens in this set. Why? Because we have clearly discussed yesterday, set doesn't preserve insertion order. What it doesn't preserve? It doesn't preserve insertion order. So we cannot guarantee on the insertion order. And again, we had also, if you ask me question why it doesn't preserve, we just came up with some more information on that yesterday, because sets try to store elements according to hash code. You got it right, friends. That is why set doesn't preserve, what is that, friends? Insertion order. So you got it right. So that's the idea about copy. And we had also discussed about two types of copying. One is direct assignment, like reference copy or address copy, and then this explicit copy, where this tries to create a new object and assigns to that. And change in S1 doesn't have impact on what, friends? Change in S1 doesn't have impact on S3 or vice versa, because this is actually explicit copy. I hope this is clear for all of you. Okay. Okay, friends, next one after this is S1 dot. You can just pop, add, update, remove, copy is fine. So clear, we'll apply this at the end of this set discussion. And apart from that, let's get into these methods. Methods of set here. Okay, what is that? Union. You can say union of two sets. Union means, right, combines two sets, removing duplicates. That's all right. Already set to that. But here, suppose if same values are there, it just combines something. So next, let me just say S1 dot S2 of union. Maybe both have same values, so I'll do one thing. I'll take one more thing and then just take few values 1, 2, 3, 4, 5. Right? Just say S1 dot R S3 dot combines of S4, S3, and then just print it. Okay, print off. So now you see here, just right, what union does. This is something like what we learned somewhere in the mathematics. So that is what this union does. Right click and run this now. Run set methods and S3 dot union of, I should say, see that why error is I should say S4, not error. Why we are not seeing output is just pass S4. So otherwise, now run this. Now you can see this. What happened? It just combined these two. Union means combine two less, right? All elements of this one and this two, just eliminating that. If any common element is there, it try to make it as a single element. That what the union does. So that is the union. You can see here in the output. Next after that is S3 dot. S3 dot another method. These are all set specific methods. Unless and until something is there on sets, we don't really apply these friends. Okay, but if it is something really needed, you can use this friends difference. Also, if you want, you see now, after I update, I just printed this. Suppose I say print of, right? S3. We did S3 dot union, right? But this time it won't show you that it is this change is whatever we are doing is this union is applied temporarily. If you want to get this updated, then there is a method union update. I'll show you that as well. Before I try this, let me just show you. Run this now. Now you can see again if I print S3, again it is showing the actual or original set. It's not showing this updated one. If you see here, S1, S3 got updated with values of S3 and S4. But S3 is not updated. This is actually a temporary change. The union is applied, it just applies union and combines all these values to S3. And this is happening just temporarily. And if you want to make it permanent, then what is that you should do? You have to apply this one here. Let me just show you. If you want to apply some set specific operation and that should be updated permanently, then you should say union. Let me first do right S3 dot. You can see union. There should be a method update as well. Difference update is there. Insertion, this update is there, but for union, I believe it's not. We don't have that. No problem then. No issues. Then you can use update instead of this as well. That also works in the same way. So if you want to make something permanent, so the method you should apply is this difference update, insertion update, intersection update. These methods we should apply. So for union, we are not seeing friends. Yeah, we don't have that update. And then you can just leave it like that. To get it updated, there is another method which is similar. You can choose update one. Next after this is so print S3 dot difference. Difference means S4. So just print it. Print S3 because when you apply this, your output will be updated in S3 or this shows the change. But here again, it comes to the basic form here. Okay. Yeah, sorry, friends. Let's continue with this difference. Let's run this. You can see here if we run it. So we don't have S1 minus S3 minus S4. It is giving us same output. So no big difference. Next after that, you can just quickly check on this S3 dot again intersection dot S4. Let's see this as well, and then print it. Print S3. Intersection means generally it prints common elements, right, friends? You know, all of us know this. It prints some common elements. Run this now, right? So probably we don't see common elements there. Okay, let's between S3 and S4, like sorry, can you hear me, right?
Hello?
Yes, yes, Shiva
Yeah.
sir.
Yeah. Okay, you have to assign it to some variable and print that one, right? You're printing
No, no,
S3.
this is not assignment. If you want to do that, there is a way of doing that. So what we have to do is I'm showing that the next scenario is that. So if any, suppose let us do one thing. Let's have few common elements. So I'll take some 1, 2 common here, so that for more this, I mean for this purpose, you can add because I'm copying S3 from S1. I will copy from S2, no problem. For testing purpose, okay, friends. So let's add some common. Also add some few elements which were common here in S4. Now you run this now. See here now. So you can see some difference now, some output here when we are applying all this. So now difference when you say S3 difference of S4. So difference in sense, right? Whatever S3 minus S4. Also, we just need to do one thing. I'll do one thing. Let me put some description here. Difference, comma. Okay. And then also we can add intersection. For that, Shiva sir, there is a method here, update. So that will directly update it to S3.
Okay. Yeah.
I'm just showing that as well. After this, we are seeing that thing only, sir. Okay, let's print this now so that we get a clear intersection. You can see here we get common elements between right. Intersection is that what we learned from maths. So we whatever elements are common between two sets. So you can see here between these two, which is common. 200 is common. 100 is common. 1 is common. 2 is common. That is what we get in the output. See here. But after that, if I print again, it is showing the original actual set, that is S3. So if you want to get this updated, whatever difference, again difference also, it just to S3 minus S4, right? What is S3? So it will try to just remove common elements between these two and put uncommon elements. That's what S3 minus S4 does, right? So in this difference, you can see here, it's just keeping 400 and 300 in S3, right? Yeah, because between these two, right, from between S4 and S3, all that common elements are removed, right? And uncommon means 300 and 400. That is just kept it as is. Those uncommon elements. Okay, fine. Now, if you want to make this thing, suppose in that case, if you want to permanently make this update, so what you can do, you can see here there is a difference update of S4. Now, if you run this time you can see that S3 get modified with the completely updated with this operation. So now run this. After that, you can see, if you see here, S3 shows you difference of these two. This 400 and 300 is directly updated, or it is, I mean, yeah, updated to S3. Right click, run this, see now. Now you can see here, so this is, you can see this. This is S3. Maybe for clarity purpose, you can print here. Okay, and here also S3, and this is, now you can observe here. What is it? When you print S3, you got that. What is that? Whatever we did after the change, applying difference, this is what the output is. You got it right, friends. So next one, when you, and this method returns none. If you are passing this, it returns none. That's why then in that case, you don't need to pass to print method. If a method is returning none, don't pass it to print, friends. This is an FYI important point to note. But difference is not passing none. It is passing some other actual result. We get it. But here you can do one thing. You can just remove this, because as difference update is returning none, you can avoid printing this. Then after updating, you can see here. You can see that this is what you should see. Then again, intersection between, now we are just left with 400 and 300, and you are applying that on S4. So common elements, we don't have any common elements between this S3 and S4 this time. So that's why it is returning empty set here. You can see here. Why this operation intersection is returning empty set? Because now let's run this, of course. Now you can see this is the output after performing difference update. Right? And then after doing that, S3 has just 400 and 300. All other elements are just updated with just this new result, 400, 300. Now we are applying intersection, means it try to bring in common elements. Common elements between S4 and S3. S4 has 400 and 300, and S4 has 1, 2, 3, 4, 500, 200. S3 has 400, 300. Any common elements? No common elements. That's why you see empty set here. You got it. Suppose if you have some common elements, then it try to again produce that result or return that result. So again, for intersection, you are doing this, right? Suppose if you think that something comes, you can apply intersection update here of S4. So you do one thing. To S3, you just add two more elements that were common. 1, 1, 1, 2. I'm just passing. Maybe again this sits as a nested set. I'll do one thing. Let's add one. To S3, I'm adding few more elements just to test the operation. Now we have two common elements. Let's run this now and close this as well. If you run again, print this S3, we should get some output here. See, we have 1 and 2 common. And we are applying this one, see here, update. When you say update, automatically, now this time, earlier we have 400 and 300 in S3. Now you did a new operation with update. Then automatically once this intersection is applied on S3 and S4, whatever result we get here. You got it right. Whatever result we have it here. That again get returned to S3. Means S3 gets totally updated with this new result. Okay. So now what we can do, this is anyhow, passing this update method to print doesn't have any impact or effect. So you can remove this, friends. Okay. Now what do you do? Let's run this now. So finally we get this one. So now this S3 got updated completely after doing this operation. That is what this difference between just intersection and intersection update. Difference and difference update. Likewise, anywhere if you find update, then you can directly apply, friends. So that replaces the result, whatever result we get from this operation in this first object, not second one. This is source and this is destination. You are combining these two and it is get modified into the source itself. Got it, right? So this is the idea, friends. So is this okay, Shiva sir? This is clear, right? Next after that. So we did complete all this methods, friends, intersection and all this. Next, We have few more methods here. So you can try all this as well. What is that? Subset is subset, all that. Suppose you say S3 dot is subset of S4. Okay. Then you have to just see what is in S4, this one. Okay, and what is in S3? We have these two, 1 and 2. Question is, by looking at that, you can easily answer here, friends. What is that? Just print it. Print S3 dot is subset of S4. Definitely S3. These two values are there in S4, right? 1, 2 is there in S4. So this returns true. You can see here. Opposite. Again, apply opposite. If you say S4 is subset of S3, then we get false, right? Means subset means that particular thing has to be present in that whatever, in whichever the set we are checking. Okay. Now you see, is S4 present in S3? Then it returns true, else it returns false. Just checking. This is something which we already know, friends. Then after that, you can also check for superset. Superset means you know. So S4 is, instead of you check superset of S3. Definitely S4 is a superset because S3 is present in S4, but S4 is not there in S3. So if you run this, it gets true. It is a superset definitely. Right. Next after that is you can also just check one more is S3 dot. You can try. We did complete almost all the API methods except one more thing. The symmetric difference you can give a try. So, but we just have 1, 2. Let's see this now. So now, if you print it, let's run this. We get this. So 3, 4, 5, 120. Right. Suppose if you want to get this result updated, what you can do? S3 dot symmetric difference, and then you should say underscore update. If this result should be permanently updated, then you should apply symmetric difference update, friends. Okay. Now, what do you do? Just now print S3 as well. I think update doesn't return anything, it returns none. Printing update is not much use for us. Okay, now right click and run this and see here. Update is returning none, but this is actually the updated value into S3. So you don't need to pass it to print because this returns none. This is an FYI. If any method is returning none, then there is no meaning of passing it to print. Only just to show you that I just passed it. Okay. So this is about symmetric difference. Right click and run this now. So this is all about methods of set, friends. Add, remove, copy, and then update, and then also union, and then difference update, intersection update. Both are doing same, but this time if we just apply intersection, the functionality is applied between S3 and S4, and that result is temporarily printed. That's all. If you want to make that permanent, then just apply S3 and S4 and just say update, then it updates. So that is the idea, friends. Okay. So this is, and these are all quick check methods like for, if it is subset or superset, all that, and it returns any that Boolean values as output. Okay. So this is the idea about set, friends. So next after that is what else we can do on sets. We don't have slicing, no slicing in sets. Okay, we don't have slicing because this is not indexed data structure. This is actually a non-linear, so that you don't have any indexing in sets in sets. So we cannot apply slicing. Maybe if you want to do slicing, what is that we should do here, friends? If you want to go with slicing, then you have to convert it to list or tuple. Then on that you should apply slicing. If you are really interested to apply some slicing, you should apply slicing. You got it right, friends? So this is the idea about what about sets and the behavior of sets and how it looks like and all that. So next thing we should start is I think we need to jump to next topic because this is enough for us. And one important of already whatever that is needed important we had discussed. Anything is there? Please let me know. I'll just a minute, friends. Yeah, that's it, friends. Okay. So we have to start with dictionary that anyhow, with the time we have, we'll take it as a fresh start tomorrow. And sorry for this small hiccup what I have here because that is emergency. I need to address that in the office. So if any, sorry for having any waiting time. So thank you. We'll stop this here because Dict will start it as a fresh topic tomorrow. This is important. We might need 2 or 3 sessions to get at least some better idea. Also, maybe I'll come up with few use cases covering all our data structures so that we can just check on that and apply on these things scenarios. Okay. Any questions? Any questions here, friends? So I'm stopping here recording.